All right, I'm going to record some help for this week's lessons 8.5 and 8.6, rationalizing denominators. I'm going to work some examples with you, and they won't be your homework problems, but they will be similar. So you're going to actually have to kind of apply what you're learning. So I'm going to use number 3 as an example, where you have 3 over 25 inside the radical. Okay, that's the same thing as saying like this. Okay, and in this case, this is super simple because you know the square root of 25 is 5. So we can actually put 5 on the bottom. Okay, and the square root of 3 is irrational, so we can leave it, in the radical form. Okay, so that's what we've done so far. But when you have a situation where the denominator is not a perfect square, say, okay, let me label these so you don't get lost. Number 7, we have 20 over the radical of 7. Okay, we don't like to do the radical on the bottom. Hopefully you've watched the con videos or the videos. I can't remember if they were con or not. Um, I don't think that, yes, they were. So you're watching a con video. There's only one this week, and it shows you how to do this. Now, this is the square root of 7. If you put that into the calculator, you get a very long decimal repeating number. No, sorry, not repeating, not ending, okay? But we don't want to keep it in the denominator. So we want to do what we call rationalizing the denominator. So if we had the square root of 7 times the square root of 7, you would end up getting, I'm going to make this super explained here, but you wouldn't have to write it like that. You would have to just think, okay, the square root of 49, what is that? That's 7. Okay, so you can skip this step when you're doing this on your own. But you see up here, we have 20 times the square root of 7. Well, we need that on top. Okay, and there's nothing that we can do to reduce that. So we're going to keep transferring it over. And so this is your final answer on a number like 7. And we will go on to a harder one. Let's do something like, I'm going to go ahead and do one of the problems from your homework. Okay, so we'll do 15. We have 4 times the cube root of 5 all over the cube root of 16. Now, you're going to have to think a little bit. This is the cube root, okay, a cube root. And what we need to think of 16 as is a 4 times 4, okay? Or even, you can even look at it as 8 times 2, okay? I'm going to do it this way because this might be our easier way. Okay, so I'm going to rewrite. Okay, we have this on top. Okay, and on bottom, I'm going to come over here and show you this is our answer, right? Well, this is what's on the denominator. Okay, now what is the cube root of 8? Well, we know it's 2. Okay, 2 times 2 times 2 gives us 8. And so the cube root of 8 is just one of these 2's. So we got that. Then we come over here and we have the cube root of 2. Okay, now we don't like any cube roots on the bottom. Okay, when it's a cube root, you're going to, sorry, I had to cough. Hopefully I coughed good enough. I covered the mic. You're going to have to actually multiply it by this. Okay, because basically we want to get rid of this radical part. And in order to get rid of it, we know we need 3 of whatever is inside. So I had to have, this one was already there, so I did multiplied by this, multiplied by this. And I'm going to pull it up because whatever you do to the bottom, you must do to the top. I know you've heard me say that over and over and over every day at school, right? Okay, so we have a lot of numbers here, right? I wish that I had more space, but I didn't give you a whole lot of space on this. So what we are doing, I'm going to combine this. 2 times 2 times 2 is 8. I'm not going to rewrite it because I've already got it rewritten up here. Okay, and we know that when I have those three together, it's actually just 2. So on bottom, I now have the 2 that was here, and then the 2 that is represented from all of these. Okay, so we come up here, we still have 4 on the outside, and I'm going to combine underneath my radical the 5 times 2 times 2. So that would be 10, 5 times 2, and then times 2. So I have the cube root of 20 right there. Now, what do you notice down here? What is 2 times 2? Well, hopefully you said 4. And so what does 4 cancel with that? And those both became 1. So your final answer is the cube root of 20. Okay, this is not a little bit of work, y'all. I realized when I gave you this assignment, you're only having 2 assignments in this week. Okay, so it might take you a little bit more than your typical assignment. All right. But just keep in mind, like what we went over before, if you have a cube root like this, kind of hard to point upside down. You have a cube root, you're going to actually have to rationalize by multiplying it by 2 more of that. Okay, so that was that. I'm going to take you on to 8.6 really quickly. Now, hopefully you remember this from class when we talked about conjugates. Okay, you can totally see through this. Give me a second. Try not to write with this marker stuff on this so it won't come through. But you can see it better when I use these magic markers. All right, so I'm going to give you an example of, let's try just plain number 1. Okay, so we have 4 over 2 minus the square root of 3. Now, if you remember, you get rid of conjugates by multiplying it by its conjugate, and a conjugate is the counterpart of it. So I'm going to go ahead and put this in parentheses. And if I were you, I'd be writing this down because this is part of your homework. Now, if you remember a conjugate, it has a minus here and a plus here, and everything else matches. So when we used to do these, we would do this times this, which gives you 4, and just write it underneath, and this times this, which this is the absolute value of 3 times the absolute value of 3. So we can multiply the insides and say absolute value of 9. But what is, sorry, I keep saying absolute value. Scratch that word. It is the radical. Where am I without Abby Klein? I hope you're listening, Abby. Anyways, this is a radical of 3 times a radical of 3. I'm going to have to listen throughout the other video if I called it an absolute value. If I did, oh my goodness, I'm going to have to re-record. So we have the radical of 3 times the radical of 3, which is equal to the radical of 9. What is the square root of 9? Yes, it is 3. And don't forget, because we have the minus involved, we have to do a minus here. So 4 minus 3 equals 1. And you might ask, well, this is a FOIL, so we go first, outside, inside, and last. But do you remember about conjugates? They only have the first and last term because this and this will cancel each other out because they're the same, but there's a negative and a positive. So we only need that 1. But don't forget what you did to the bottom, you must also do to the top. So we have 2 plus the square root of 3 on top. So don't forget, we have 1 on the bottom, so I don't really even have to put it. I don't even know why I put a fraction bar. But we are going to go ahead and distribute. So this is 8. And we're going to multiply 4 times the radical of 3. Oops, almost forgot my 4. And that is your final answer on that. Okay, so that was number 1. I'm going to do one more with y'all, and I'm going to do something that might be a little bit more difficult. Let's see what we can do. Let's go ahead and do number 17. Okay, it has a negative involved, and I'm going to go ahead and put that negative on top just to make my life and your life less complicated. So we have the square root of x plus 1 on bottom. If we want to get rid of that square root of x, which that's kind of our goal in the lessons this week, we are going to multiply, I'm going to put my parentheses around there, by the conjugate of this. Okay, don't forget, let's do this while we're thinking of it and multiply it on top. Don't forget, it has to be the same. Okay, so when we multiply the bottom, what is the square root of x times the square root of x? X. So it pulls off the radical when you do that. If you're not remembering or not realizing why, just think of this. What is the square root of anything squared? It's that anything. All right. So then our inside and outside terms go away. So we don't need those, but we still have this last one. Okay. So the x minus 1 is going to be our denominator. And then I'm going to distribute the negative 2x to my 2 parts. So we have negative 2x times the square root of x. There's no way to simplify that. And then we have a negative and a negative. So what does that make? A positive. So then we have plus 2x, all of that over x minus 1. All right, so that is what we end up as our answer, and that's your final answer. Hopefully you have followed me. Number 11 has a square root on top and bottom, but you don't ever have to worry about getting rid of the radical when it's on top. Okay, you are only dealing with getting rid of radicals when they're on bottom. All right, before I make this video go forever, I'm going to stop it there. Hopefully it helped, and I will chat with y'all later.